Hey, Ms. Rivera, I'm really scratching my head on this one. I've been trying to figure out how to translate the triangle with vertices A at the point 2, 1, B at the point 4, 3, C at the point 1, 5 by the translation vector 3, -2 to find the image coordinates. Nothing is making sense right now, and I'm a bit stuck.
Fair enough. This problem packs a lot into one sentence, Cody. The trick to these translation problems is understanding what kind of transformation a translation is and how it impacts the figure. First, can you remind me, what do we call transformations that preserve the size and shape of a figure?
I think those are like reflections, rotations, and translations. The ones that keep the shape the same. Is that what you mean, Ms. Rivera? I'm curious if there's a specific name for that group.
That's exactly right, Cody. Those are indeed reflections, rotations, and translations. We call them rigid motions because they don't change the size or shape of the figure. Now, focusing on this problem, we're dealing with a translation. How would you describe what a translation does to a figure?
Okay, so a translation just slides the figure, right? It moves it from one spot to another without turning it or making it bigger or smaller. It's like shifting something across a table. Does that sound about right?
Yes, Cody, that's a perfect way to describe it. A translation literally just slides the figure to a new position without changing its orientation or size. Now, in terms of coordinates, if we have a point, the point x, y, and we translate it by a vector, a, b, what do you think the new coordinates x prime, y prime would be?
So, if we have a point x, y and translate it by a vector, a, b, I'm thinking the new coordinates would be the point x minus a, y minus b. Does that sound right, Ms. Rivera? I remember we subtract sometimes, so I'm wondering if it's like that here.
I understand why you might think of subtracting, Cody, but for a translation, we're actually adding the components of the vector to the original coordinates. Think of it this way. If you're sliding a point to the right by 3 units, what happens to its x-coordinate? Would it increase or decrease?
Oh, right. If I'm sliding to the right, the x-coordinate would increase, so it makes sense to add. So then, for a point x, y translated by a, b, the new coordinates would be the point x plus a, I plus b. Is that the correct way to do it?
Yes, Cody, that's exactly right. For a translation by a vector, a, b, we simply add a to the x-coordinate and b to the y-coordinate. This gives us the image point x plus a, y plus b. Now looking at our problem, what is the translation vector we're working with?
Okay, so the translation vector in our problem is the point 3, -2. So a would be 3 and b would be -2. I'm curious if we just apply that directly to each point now that we know the rule.
You've got it, Cody. The translation vector is indeed the vector 3, -2, so a equals 3 and b equals -2. Now that we know the rule, the point x, y maps to the point x plus a, y plus b. Let's apply it to our first vertex, a, at the point 2, 1. What would be the coordinates of a prime?
Okay, so for a at the point 2, 1 and the vector 3, -2, I'd do the point 2 plus 3, 1 plus 2. So a prime would be the point 5, 3. Is that how I'm supposed to apply the rule, Ms. Rivera?
Good try with a prime, Cody. You correctly applied the translation to the x-coordinate. However, let's recheck the y-coordinate. Remember, our translation vector is 3, -2. What happens when you add a negative number to the original y-coordinate? Can you try that one again for a prime?
Oh, I see. Since it's 1 plus -2, that would make it 1 minus 2, which is -1. So a prime would be the point 5, -1. Is that what I'm supposed to do with the negative part of the vector, Ms. Rivera?
Exactly, Cody. You've got it now. When adding a negative number like -2, it's the same as subtracting 2. So, for a at the point 2, 1, translated by vector 3, -2, a prime is indeed the point 2 plus 3, 1 plus -2. which simplifies to the point 5, negative 1. Now, let's move on to vertex B at the point 4, 3. Using the same translation vector 3, negative 2, what would be the coordinates for B prime?
Alright, for B at the point 4, 3 with the translation vector 3, negative 2, I'll do the point 4 plus 3, 3 plus 2. That means B prime would be the point 7, 5. Does that look right for the second point, Ms. Rivera?
You're consistently applying the translation to the x-coordinate correctly, Cody, which is great. However, I see a similar small oversight with the y-coordinate for B prime. Remember, the y component of our translation vector is negative 2. How does adding negative 2 affect the original y-coordinate of 3? Can you recalculate B prime with that in mind?
Oh, you're right. I keep forgetting the negative sign for the y part. So for B at the point 4, 3, it should be 3 plus negative 2, which is 3 minus 2, making it 1. So B prime would actually be the point 7, 1. Is that finally correct for B prime, Ms. Rivera?
Yes, Cody, that's exactly right. B prime is the point 4 plus 3, 3 plus negative 2, which simplifies to the point 7, 1. You've successfully handled the negative component of the vector now. Great job. Now for our last vertex, C at the point 1, 5. What do you get for the coordinates of C prime?
Okay, for C at the point 1, 5 and the vector 3, negative 2, I'll do the point 1 plus 3, 5 plus negative 2. So that would be the point 4, 3 for C prime. Is that correct, Ms. Rivera? I'm curious if I finally got it right without a mistake.
Excellent, Cody. You've successfully calculated C prime as the point 1 plus 3, 5 plus negative 2, which simplifies to the point 4, 3. You've applied the translation rule correctly to all three vertices. So, to summarize, the image coordinates for the translated triangle are A prime at the point 5, negative 1, B prime at the point 7, 1, and C prime at the point 4, 3. Congratulations, you've solved the problem.
Thanks so much, Ms. Rivera. I really appreciate your help with this one. I finally get how to handle those negative numbers in the translation vector. That was tricky for me. It feels good to finally figure this one out.